Okay.
I feel like I'm sitting on a grill. I'm supposed to.
Alright, so I need everybody to open the bag and find the milk chocolate bar. None of the other types, just the milk chocolate. This will be the light brown packaging. So, there you go, you got it right there. Can you hold that up for me? There you go. When you have it, hold it up. Hold it up nice and high. Everybody got it? Awesome. So go ahead and open it up for me. And it might be a little bit melted, so it might be a little bit hard to do this. Oh, they're a lot melted. So what we're going to do is you're going to put one hand on each end of the chocolate bar. Okay? And you're going to try and break it in half. Okay? You want to have one single round. There you go. It's too melted. There you go. Yours worked out really nice. So some of them might be a bit too melted, but if you got it to break in half, then you're good and you guys can go ahead and eat it. If it's too melted, go ahead and eat it too, because it's not going to work. So somebody who got it to break in half, can you raise your hand and tell me how hard it was to do? Kenton? It's pretty easy. So the next one that we're going to do is we're going to do the dark chocolate. So can you guys pull out the dark chocolate for me? This one will probably be just as bad. So go ahead and do the dark chocolate same way. Two hands on the bar and try and snap it in half. Make sure you put your trash back in your bag. We don't want to leave any trash on the ground. Did anybody get theirs to break? Raise your hand. What was it like? Did you get it? It wasn't that hard? Okay. So when you guys get home, if you have chocolate at home, you can try this at home, okay? The milk chocolate will actually feel different than the dark chocolate when you break it because there's different characteristics to it, just like anything else you see in the real world. And we can try it with the other one too, but that one's probably going to be pretty melted as well. So. Go ahead.
Since the last one actually is milk chocolate with white, it says that on the back. But when it melts, well, you might actually see something.
Yeah, and actually that one will break completely differently than the other ones. If they were all solidified, that one would feel the most different because it would have holes in it. So that's something that can happen in your materials. It'll be weaker and it'll be easier to break. So make sure you put all your trash back in your bag. They need to end up in the trash can, guys. Thank you.
So now I'm going to introduce to you Brian Esquivel, and he works in my research group at UD, and he is a soil chemist. So he's going to show you what soil chemists do. And before we get started, I'm going to need a volunteer. So you're close. We'll go with you. Miss Miley Reese.
So, hey everyone, my name is Brian. I'm currently doing an internship at the University of Delaware, and I work in Autumn's group. She's a great teacher. She's shown me a lot, and I'm here helping her out, and I'm enjoying it so far. So, what I study is soil chemistry. But what exactly is soil chemistry? What do soil chemists do? Soil is a complex thing. Thank you. Soil is a complex thing. If you were to grab a handful of dirt you would see, even with just your eyes, you would see that each piece, each individual soil particle has a different size, compared to the one next to it. And this is a very important property of soil because a lot of the properties of soil depend on the type of soil, the size of the soil particle, because the smaller that the soil particle is, the more ability it has to bind nutrients. And in other words, it becomes more sticky, and it's able to hold on to these nutrients really well the smaller the soil particle is. So when a seed is to germinate, to develop, to grow, its roots develop and they start to spread in the soil, and through different processes, their plant roots are able to absorb nutrients. So if I could get another volunteer. Alright, so I said earlier that soil properties depend on the size of the soil particle. There's three types of soil particles in every soil: sand, silt, and clay. Clay is the smallest, silt is a bit bigger, and sand is the largest. Sand, you'll see it at the beach. A nice soil that has everything in good ratio and good proportions, which is perfect for plants to grow. It's soil that you can find under a lot of vegetation, like decaying organic matter. But the idea is this: you start off with sand, and because it's bigger, it's sticky. Sticking ability is low, so when nutrients are exposed to the soil, you'll only get 2 nutrients stuck to it. But the smaller that the soil particle gets, like silt, the next smallest, you get more nutrients. And then once you get to clay, its sticking ability to nutrients is even greater. So when you're a plant and you need nutrients to grow, you really want to be in a soil that has a lot of nutrient stuff. So you want a lot of clay in your soil. Not a lot, not in excess, but just enough. So when you're a root, you have all of these nutrients to take. But, thank you, Jeffrey. So that's the idea of soil particle size. But you also have other things that can go into the soil, a lot of contaminants. If you're ever in an area and you see those industrial factories and you see all this white smoke, sometimes they can give off contaminants that are released into the environment, and they can dissolve in rainwater. But rainwater also goes back to the soil eventually. And it's the same idea. These contaminants can bind to soil. Which is good, because a lot of the groundwater and irrigation water is the water we give to crop plants. Through several techniques, we irrigate crop fields, we water them. But we want these nutrients to be absorbed, to be stuck to the soil, to be bound to the soil. We don't want them to go into the groundwater, because a lot of this groundwater is the water that we use to drink and even to irrigate the fields. So we want these nutrients to stay in the soil, not in the groundwater, beneath the soil. And the idea here, okay, so here we have 3 soil samples. This is sandy soil. This is soil mixture with a good combination for seed. And this one is just potting soil. So this one is rich in organic matter. And real quick, organic matter, when it's decomposed, it comes to a certain point where it releases nutrients back into the soil, which then bind to the soil particles, such as clay particles. Now, as you can see, the sandy soil, when the grape drink was poured into the sandy soil, it didn't change color, because that soil, which is bigger, didn't bind a lot of the compounds from the grape juice, the grape drink. And this one is the soil mixture, which also has clay in it, the smaller clay particles, and it bound a lot of the colorant from the grape juice. And this soil mixture has a lot of organic matter, which is smaller, or just as small as clay, so it really binds a lot of contaminants and nutrients. And so you see, the smaller that the soil particles get, the more they are able to bind to certain other compounds, such as nutrients and contaminants.
And then soil also has an ability to filter just contaminants and big particles out of water. So we have some really dirty water here. You can see there's some big particles. And you see the water that's coming out the bottom is pretty clear, and all of the big pieces of contamination that were in that water have come out of it from all the samples because they all do a really good job of filtering out particles. Thank you, Fran.
Thank you, everyone.
So next we have Schwan Yu. He is also in my research group, but he is a civil engineer.
So I'm Xuan Yu. I'm a civil engineer. So what I'm doing is to understand how to protect our land. Because have you ever heard about sea level rise? Okay, so did you go to beaches to play with sand? But if the sea level is going to rise, all the beach is going to disappear. So today we're going to demonstrate how we can build dams, the barrier island, so can protect our land. So here is some, yes. So, for example, we assume our land is at the table and the sea level is like this level. So now I'm predicting the storm surge, and in each case, I use 3 pieces of blocks, but I place them in different shape, but I use the same amount of wind to blow them. So to simulate the seawater come into inland, so we can see which way is the best we can protect our land better. Now you can see in the current sea level, the storm surge is below. It cannot impact the land. So if I blow at the bottom, there is no impact on our beaches. But if I blow a little bit higher, which means the sea level is going to rise, our dam is going to destroy. The second one also retreat, but the third one, they can stay safer. So I'm going to help the civil engineers to design the best practice to kind of protect our beaches. Thank you.
Thank you, Sean. Did everybody get a chance to see the shapes? If not, I'll leave them up here so you guys can see which shapes are the most effective for the barrier. Next we have Grace Cords, and she wants to be a veterinarian whenever she graduates.
All right, so who knows what a veterinarian does? Jack. Exactly. So everybody knows or has seen one of these, right?
Yeah.
This is called a stethoscope. And so generally, your doctor would use it to check your heartbeat. Well, I'm going to use it to check Sky's heartbeat. This is Sky. She's an Australian Shepherd. So I need a volunteer. Kenton. Now what you're going to do
hold this right here. All right. You all will be glad to know that her heartbeat is very normal and that she's a very happy and healthy stuffed animal. Now, a stethoscope is a piece of technology that was used to help understand what's going on inside, because we can't see in there. Technology also helps to be able to use an X-ray to see what's going on and get a better diagnosis so that we can help and make the animal population healthy when they're sick. Thank you, Grace. So today I'm here, as you all know, I'm a soil chemist, but today I'm here as a wildlife ecologist. That's the outfit. So I study ducks in the wetlands, and I'm going to show you a demonstration about how things in the ducks' environment will affect how they live and how their populations change. Because that's what I do. I want to understand the change in population. How many ducks do we have in this group? So I have two different types of ducks here. One just sits on the water, and when he eats, he tips over and gets his food that way. It's called dabbling. I have another duck here who doesn't dabble. He likes to dive. So he'll be flying along and whoop, he'll go under the water to get food. So he'll be able to reach a lot more food whenever he's eating. So what we're going to do now is we're going to look and see what a dabbling duck, the mallard down here, what would he see in his wetland that we have here on this chair? What would he see in his wetland that he can eat for food? So can I have a volunteer? Yes. Cheyenne is going to help you. So Cheyenne, I want you to use the critter scope in the front. And I want you to put it down in the water, just a little bit. And I want you to look, use it like a magnifying glass, and tell me what you see that you think a duck would want to eat. So there are worms in there. Yeah, they kind of look like eels a little bit, but there are worms. What else? Yeah, so there are mollusks in there. They'll eat the mollusks. What else might they want to eat? Do you think they want to eat the plants? Yeah, so they'll eat the plants and the plant roots. If there were bugs or fish, they might also eat those. So if the environment is impacted negatively, if all of the fish and the worms and the mollusks and the vegetation go away, what do you think will happen to the ducks? They'll go away too, right? Because they won't have anything to eat. So that's what I try to understand, is how the population of ducks change whenever they don't have enough food or the right kind of conditions to thrive. So thank you all so much, and now Doug will talk.
Let's give all of our presenters another round of applause for all that scientific information they provide us today. My name is Doug Krause, and I'm currently serving as the State 4-H Program Leader here in Delaware. It's my pleasure to be here and see all these 4-Hers out in front of me, here with inquisitive minds I learned today. And some people might ask, how did we get here today? Well, you may have heard of this, or you may have read about this, or you may have seen emails or things on Facebook, but there was a campaign launched by National 4-H called 4-H Maroon. And it gave the opportunity for states to have their alumni check in. And that state that could get the most alumni to check in per capita, even though we're a small state, per capita means based on our population, that state was going to be awarded a Science Innovative Incubator Award, $10,000. Guess who won that award? Delaware won that award. Delaware won that award, and that's why we're here today. And because of that award would not have been possible without a sponsor. And that sponsor, and I haven't had the opportunity to meet the representatives yet, even though I see one walking in the back there, but HughesNet was the sponsor of that award. And they are here today, so let's give them a big round of applause, please. And I was just at my grandmother's house yesterday taking care of her mail. She turns 93 this week, so I do have to look at her mail, but I have seen this before and I've heard people make remarks to me about this before. But she got a internet mailing about signing up for internet at her home address. And on the back of that mailer, and I want to tell HughesNet this because your advertisement does work. It says, HughesNet through 4-H Council, working together to inspire the next generation of leaders in science, technology, engineering, and mathematics. So again, another big round of applause for HughesNet, because that's really why we're here today, because of their generosity and their desire to work with youth, to give them opportunities to learn and to grow, and to see and to be, and learn all about science. But we did some research, or one of the staff members did some research, and they found out that Delaware was actually ranked 25th out of all states related to STEM education in public schools. 25th out of 50. Some people would say that's okay. That's halfway. I don't think that's okay. We're the first state, and where do we need to be ranked? We need to be ranked first, or at least in the top 10. So we're going to continue in Delaware 4-H to work with our science mission mandate. And if you did not know, science is one of our 3 national mandates that we work with. And we're going to work with the state of Delaware, we're going to work with public schools, and we're going to work with any initiatives that might come out of the governor's office to keep providing opportunities to you to learn more about science. Now, when I was in school, I probably shouldn't say this, but I'm going to, science was not my thing. However, when I've gotten younger or older, I keep saying I'm young, but as I've gotten younger, and I watch these little experiments up here, and I see scientific experiments done, I'm just fascinated about science. So I want to challenge each and every one of you, as you're younger than I am, to take that opportunity while you're in school to really, really look hard at science. There's so much you can learn. There's so much you can do. There's so many opportunities out there. So today will be one of those opportunities. And we again want to thank HughesNet for providing that opportunity, providing the funds for us to have this opportunity here. So when you go home and your parents or your grandparents or anyone asks you why you were here today, remember, it was HughesNet, and we thank you again for that opportunity. Thank you, Kristen.
Okay, at this time we're going to go ahead and get started. So we're going to take a minute to divide you into your groups. Notice on your name tag you have one of 4 different science professions. You have either a doctor, a geologist, an astronomer, or an engineer. Is that the 4th?